Hello guys. Today I want to talk about triangles and how we prove them congruent. Basically, we prove them congruent with our side, side angle, side, and all these other relationships that if they have, then they have to be congruent. I'm going to show you where that comes from. Basically, what we have to do is study triangles and their sides compared to their angles. So let's call this A, B, C, C, B, A. Yeah, this should actually be backwards. So just to let you know, angles are supposed to be written with capitals, and sides are normally written with lowercase. It's just a convention. But anyways, well, we have to actually give you some numbers. Let's call this, I don't know. Actually, no. Let's just go like this. This actually might take like 2 videos, so if it cuts off, just be ready for that. So the relationship we have to notice is that as this angle grows, gets bigger, then this length has to get bigger, right? And as this angle grows, we all know that a triangle has 180 degrees, then either one of these is going to have to lose angles. You have to lose like its length. So let's make this be like this, right? And let's make this the same length. Well then, when these finally meet, the angle is probably going to be like that, right? Very, very small, because this one gained them. So that's a relationship that's important to know. As an angle grows, another one gets smaller, and the length gets bigger. Got bigger. So basically, what we have to notice is that when we have two triangles, we have to look for certain ways to prove that their sides are equal. Because basically, based on what I just showed you, if they're, let's start with an easy one. Side, side, side. If all the sides are equal, think about a triangle. Say we have a side length of 3, side length of 4, and a side length of 5. Should actually be a little longer, but yeah. If the sides are all equal, is there any way to put these sides together that will not form a triangle that is that is congruent? No. You have 3 sides. Let's pick this side and draw it there. 3. Let's do this 1, 4, 5. That is the only way to draw it. Okay, well, let's switch these two around. Right? This is 4 now. This is 5. You see, it's the same triangle, just flipped. There's no other way to draw it. So that's why side, side, side guarantees that the triangles will be congruent. Let's look at another one. Angle, angle, side. Angle, angle, side. So let's have this triangle and this triangle. Let's say that this angle and this angle are the same. This angle and this angle are the same. and this side and this side is the same. Now, based on this, we know that a triangle has 180 degrees, correct? So when we have two of the sides, then we obviously with no doubt, know that the third side has to be equal, correct? So really now we have angle, angle, angle side, right? So I don't have like angle, angle, angle side. All the angles are equal, and we have a side that's equal. If all the angles are equal, and we know from the properties of a triangle that there's really only one way to put a triangle together, because if you have three sides, one of the sides has to be touching the other two. It doesn't matter if this side is touching this side or if it's touching this side. You know, you're going to come out with the same triangle. It might just be flipped a different way, but it's always the same triangle. So if three angles are the same and one side is the same, then you can conclude for sure that these sides have to be the same, because these angles are not ambiguous. They cannot grow and get smaller in any way. So the relationship between this angle and this side is fixed. It cannot change. So that means that the relationship between this angle and this side is defined. And without actually calculating it or anything, we know for sure it has to. Before degrees were invented or thought of, the Greeks were able to come up with this